I've set myself a challenge of making a clock that displays my YouTube and Twitch subscriber counts using tools that I've showcased on the channel. But can I pull it off? Let's find out.
Diving into complex problems can be a bit daunting, but there is a secret weapon in our arsenal that can help us get through this. It is a skill that needs to be honed, but problem solving can get us through this.
If you solve one problem, then you solve the next one, and then the next. And if you solve enough problems, you get to come home.
The first problem we need to solve is what features we want this clock to have. We need it to connect to the network, display the time accurately, display the YouTube channel subscriber count, display Twitch channel follower count, display the Twitch subscriber count, and display a change in the number, whether it be positive or negative. Now we know the features we want the clock to have, we need to figure out what hardware we're going to use. The hardware we need is a controller, a display, a power supply, and a case. Considerations for the controller is something that we can program and something that has enough pins to be able to drive the display that we want to use. To reduce the number of pins that I need for the project, I'm going to use a clever LED. The WS2812B, or NeoPixel as it's more affectionately known, only uses 3 pins to drive it: 5 volts, ground, and a data pin. These LEDs can actually be daisy-chained to make strings or a matrix that we can use for our display. So for the controller, I'm going to be choosing between the ESP8266 and its bigger brother, the ESP32. Both of these boards can be programmed with the Arduino IDE. Both have a wide range of supported libraries, such as the Adafruit, NeoPixel, and Matrix libraries that we're going to need to use to drive the display. Either of these microcontrollers would be a good choice. However, I'm going to use the ESP32 as I've got a bunch of bare modules that I'd like to make a custom circuit board for sometime in the future. Now we have to think about the power supply, and we've got a bit of a problem. While the NeoPixel is a neat little package that we can drive with 3 pins, it consumes quite a bit of power. Each LED has 3 LEDs within them, one for red, one for green, and one for blue, and combined they'll give us white light. Each of these LEDs can consume up to 30 milliamps, so at full brightness this will be consuming 90 milliamps. The display we're using is 8 by 32 pixels. If we were to make this display completely white at full brightness, it would be consuming a whopping 23 amps. It's unrealistic to think that we're going to get a power supply at that rating that's going to be acceptable for the project. So how do we solve the problem of the power consumption? Well, there's a couple of things to consider. Firstly, we can reduce the brightness of the LED. Bringing it down to 15% of its maximum brightness still gives us a bright LED for the display, but reduces the power consumption significantly. At this brightness, if we made the panel completely white, we'd now only be consuming 3.5 amps. We can also consider that the panel is never really going to be fully illuminated, because we're only going to be displaying numbers and not the full display. Planning ahead is going to be essential if we're going to make the transition from our concept to a first prototype as smooth as possible. So before we get into building the prototype, we need to think about what sort of tools that we need. I'm going to be using a breadboard for prototyping, an ESP32 dev kit, some jumper wires to make temporary connections, a soldering iron for making permanent connections, a programming tool to be able to program the ESP32, and in this case we're using the Arduino IDE, a CAD program to design the case, and a 3D printer to actually make the case. Now I'm not going to go into how to set up the board within the Arduino IDE. There are plenty of videos on YouTube on how to do that would explain that far better than I can. I'll post a link in the description that goes through a tutorial of how to install the Arduino IDE and set up the ESP32 ready for programming. So I'm not a programmer. So how can I even dream to start this project from a programming standpoint? The answer is examples. There are loads of different projects that are out there, and you can use them as an example of how to do something. Examples can be found within the Arduino application itself, but also you can do internet searches and find examples on places like GitHub. To get the project started, let's start by getting connected to Wi-Fi. A lot of examples for Wi-Fi hard code the SSID or the name of the Wi-Fi and your password directly into the project. But I want a bit of flexibility. I want to be able to change the Wi-Fi details as we see fit, whether that's because we've moved to a different location or making the project available to others so that they can use it within their own Wi-Fi networks. After a bit of research, I found a Wi-Fi manager that enables you to program the Wi-Fi credentials on the fly using a web-based portal. I'm not going to go into the specific details of the example, but I will link to a video by Brian Locke that goes through a number of scenarios that you can use the Wi-Fi manager for. The Wi-Fi manager essentially sets us up with a portal that we can use to program our Wi-Fi credentials. It scans for wireless networks, allows you to select one and type in your password, saving the credentials of the Wi-Fi on the internal storage of the microcontroller for use when we restart the device. Next up, we need to control time. Neither the ESP8266 or the ESP32 have the capabilities of keeping accurate time without a real-time clock. So how are we going to make a project that cannot keep time accurately? Well, now we have the project connected to the network, we can query something called an NTP server. Technically, this is an inefficient use of data, but in the world of broadband, there's plenty of data to go by to allow us to query the NTP server quite regularly in order to keep accurate time. In order to query the time server, I'm going to use a library found on GitHub called EasyTime. EasyTime takes variables such as time zone and it outputs the correct time for that location. You can then format the time for 12 or 24-hour clock, include the day, a month, or using text formatting strings. For our project, we need the time in 24-hour format. It needs to include the hour and the minute for the UK time zone. Next, we save that data into a variable and call the time function at regular intervals in the main loop of the program to keep that variable updated. Now we have the project querying time, we can output that information to the serial monitor to see it actively updating. So we've got it connected to Wi-Fi, we've got it keeping accurate time. Now we need it to connect to YouTube and Twitch. How the heck are we gonna do that? Thankfully, both YouTube and Twitch have something known as an API. Technically, an API stands for an Application Program Interface. In layman's terms, it means that we can talk to both YouTube and Twitch in order to get data back. We have to follow some rules or standards in which to communicate with YouTube or Twitch, but we should be able to get the data that we require from those APIs. Again, the internet is an awesome resource, and doing some searching I found a video from Brian Locke detailing a library that queries YouTube for information. From this, we should be able to get our subscriber count. The library requires us to have an API key and a YouTube username that we want to actually get this information for. So how are we going to get that information into the program? Well, the Wi-Fi manager enables us to pass custom HTML code, so we can write a form to capture the information that we need and save it to the internal memory of the ESP32, much like we did with the Wi-Fi credentials. I need to do this for Twitch as well, so we'll add some additional fields and some checkboxes so we can do some logic later in case we only want to query one service versus another. Once we've added the library to the Arduino IDE, we include that library into our program. To make the form work, we add some global variables to hold the information stored when we submitted the form. Now we have to make a YouTube API call. In this API call, we have a YouTube subscriber count variable, which calls the subscriber count from the library. This YouTube subscriber count global variable would then be used later on for us to be able to display that information either in the serial terminal or on the display itself. Unfortunately, looking at the Twitch API and Arduino specifically, I couldn't find a library that would return the information that I needed. So I took to YouTube again, searching for how to communicate with APIs. And I found another link, which is in the description below, from Brian Locke again, that details how you can communicate with an API. Using this information, I was able to use the variables that we'd stored in the memory of the ESP32 and get it to query to get my subscriber count and my follower count. Using a bit of code to print this information out to the terminal, we can actually watch these values change as we test with a subscribe or a follow on YouTube and Twitch, just to make sure that the numbers are actually incrementing correctly. So we're connected to the internet, we're capturing accurate time, we've collected the information about our YouTube and Twitch APIs, we're getting the data back to tell us what our YouTube and Twitch subscriber counts are. Now we need to put this information onto the display. To be able to display this information on the LED array that we've got, we need two libraries. One is the Adafruit NeoPixel library, which controls the NeoPixels themselves one by one, and the Matrix library from Adafruit, which simplifies being able to write to a matrix for text or numbers. Once we've connected everything up, we can use the matrix.print functionality of the library to be able to put the information on the screen. So now we have the data being displayed on the NeoPixel display. We need to put this in some sort of enclosure so it's a little bit nicer to look at and possibly hang it up on a wall. The first thing that I noticed that the display is a bit difficult to read when looking at it as a bare. Placing a piece of paper over the display itself reveals the text a little bit clearer, but it's not necessarily aesthetically pleasing. As an experiment, I designed a diffusion matrix in an attempt to try and make these pixels look a little bit more appealing. Placing a piece of paper over this diffusion matrix reveals nice, crisp, square pixels, which I kind of like the look of. Arguably, this could be any shape, so you could get really creative with some of these designs. Now, to make the diffusion matrix, we're going to pull off a neat little trick with a single color 3D printer. The actual diffuser is going to be printed in a white material, where the rest of the enclosure is going to be printed in a black material. To pull this little trick off, what I'm going to do is print the diffuser first, and as we transition into the diffusion matrix cells, I'm going to add a color change operation within my slicer. This means the 3D printer will move the print head away from the print job, retract the filament, and allow me to change the filament color, enabling me to print the remainder of the enclosure in black. And here comes the next problem. Due to the size of the print, I'm experiencing warping at the corners. The enclosure is printed out of PETG, which should be warp resistant. However, that doesn't seem to be the case here. After the first attempt failed, I tried to reduce the draft that's around the printer, this being caused by the exhaust fan of the control box. While this did improve things, it still resulted in a failure. So the last attempt was to reduce the cooling fan to 20% and also include a brim. While this was almost perfect, there is still a small amount of warpage that's going on, but I think we can live with this for this prototype. Now we have everything we need to complete this project. It's time to put it all together. First, I soldered the connections to the ESP32 dev kit. Next, I put in some PCB standoffs that go on the back of the bracer that holds the NeoPixel matrix in place. Next, I add some brass inserts to the case. This will allow me to screw the back of the case on and have a nice, tight, secure connection. Now it's time to slide the display into the case and align it with the diffusion matrix. Once that's done, the bracer can be inserted. A little bit of persuasion gets the little clips to lock into place perfectly. Then it's time to install the ESP32 dev kit, a power switch, and a power connector. Once the back is on, it can be powered up and put in pride of place on the back wall of the studio. Oh, I forgot to mention, during the programming phase, I added some additional variables that captures the previous state of each of the values that we're tracking. When there's a change, it triggers an animation of either a green or a red loop around the text to indicate that the number's either going up or down. And that's it, the project is complete. Who'd have thought that someone like me could have actually made something like that? There'll be links in the description to all of the supplies that I used during this project. If you like this project, why not hit the subscribe button for the next one? It might be illuminating. And if you want some more information about how I use these tools, why don't you click one of the videos just here.